Hi guys. So today we're talking a new topic this week, piecewise functions. Um, piece. Just think of them as we're cutting graphs into pieces and only taking certain parts of it. And that's going to make a lot more sense in a few minutes, I hope. All right, so here's an example of one. I went for a walk today. I started in my house. Then I walked 2 miles in 30 minutes. So what we should do, as we used to do, is underline your verbs. I went for a walk today, and it's not letting me underline my verbs. I started at my house, then walked, and I would circle your 2 miles. So here we have our verb, we walked. This is the math, right? I'm sorry, I can't write over it. Here's the math. I walked 2 miles in 30 minutes. Here it is. Let me see if I can highlight it. Here it is. Nope, but you see where I'm talking. I met up with my bubble buddy at a park and we talked for an hour. I noticed what time it was and headed home again, making it in 20 minutes. Bubble buddies, remember should be practicing social distancing right now, but as we're sitting here safe, what a bubble buddy is figuring out who else has been having safe behaviors and connecting with them and just staying within that little group so that no other things are introduced to it. It's how we're going to have to live this summer. So just my thought for you. All right, so met up with my bubble buddy. Okay, well, I have a graph here. What am I going to do? Well, I know that I'm walking from home, right? I went from home. So oftentimes, usually, if there is time, that is going to go here on your x-axis. Okay, the time is going to be your independent variable. Sorry for seeing all that. Time is going to be your independent variable, and that means that it's going to happen regardless if anything else happens. Regardless if I'm walking or not, time passes, right? And then, but what am I measuring with time? Well, I'm trying to see how far I am from home, or distance from home. Let's do it that way. That's the nice proper way. Let's use a smaller pen. Distance from home. Okay, so what did I have? I got as far as 2 miles, so maybe I'll make each of these a mile. Why not? This is 1 mile and there's 2 miles. Oh, it's short, but that's okay. And then time. All right, well, I know that there's something about 30 minutes, an hour, another 20 minutes. I don't want to make this super duper long. So maybe I'll make these each 15-minute long. So this would be like 30, so 15, 30, 45, an hour. So what that's showing me is that so I didn't write that, but this is what's here. This is 15, this is 45, this is 60, 75, I'm not worried about it, 90, 105, 120. We may have to go in that, 135, 150. Good. Whew, sorry. Sorry for that moment. But each one of these lines represents 15 minutes, but you don't have to write that every time. I'm going to take this out even because it looks really messy and I don't want it to get too muddled. But every single one of these blue lines here represents 15 minutes of time. All right, so I went for my walk today. I started at my house. So if I'm starting at my house, then how far away am I from home? I'm not. I'm there. And I walked 2 miles in 30 minutes. So I know that I want to end up at 2 miles at 30 minutes. All right, that's a normal pace, I guess. I'm going to connect those dots. So that's my first piece here, right? I met up with my bubble buddy at the park and we talked for an hour. So am I getting further away from home? No, I'm just, from the word problem, it looks like I'm just sitting there and I'm sitting there for an hour. So it's not increasing my distance from home. I'm not getting closer to home. It's just maintaining for 60 minutes, right? So from 30 minutes to 90 minutes. I noticed what time it was and I headed home again, making it in 20 minutes. So if I went to here, that would be 30 minutes, right? And that's too far. Could have picked a better number here. I know that there's 15, so it's going to be a little bit more. So maybe like right here, and I'm going to just connect those. I know I connected them backwards, but that's okay. And this is a little bit of an estimate, and that's all right. There is a piecewise function. Here in the first 30 minutes, one piece of it is that I walk 2 miles. My next piece, the 60 minutes, is I didn't walk, but I stayed. I was sitting with my bubble buddy. And then the reason this one is going down is because I'm ending up getting closer to home, right? I'm making some pace. It's going to be a little bit faster, 10 minutes faster than this one. So that means my slope should have, or gradient, sometimes you'll hear it as a gradient if you have any English, UK background. Gradient is actually steeper. Yes, it's more negative. This one has a slope. Well, we could do the slope there. I'm not going to get too far into it, but this slope is going to be a little less steep than this slope because I wanted to get the same distance in a faster time. I did it in 20 minutes as opposed to 30 minutes. So that's just an example. If we pull up another one, on the 12th floor, I live on the 12th floor of an apartment building. When I have to get the mail, I can take the elevator or I can take the stairs. How could I show each of these routes using a piecewise function graph? All right, so I live on the 12th floor. How do I want to label this? All right, well, this could be 1, 2, 3, 4, 5, 6, 7, 8. I didn't give myself enough space. Okay, so let me think about that. How can I draw that? 8, but I need to show 12. All right, maybe each one of these lines will count for 2, right? And why did I know that this was going to happen? Why did I put my floors over here? Well, I know that what floor I'm on is going to depend on if I've gone to get the mail yet or not. So 4, 6, 8, 10, 12. All right, I know I live on the 12th floor, right? Oh, and I'm trying to do 2 different graphs here. So let me slow down. The first graph, I'm going to think about the elevator. If I'm feeling a little bit lazy, which I don't do as often anymore. Now that I'm stuck in my apartment, I do take the stairs from time to time. But let's just think about old time. I used to leave my apartment. Maybe it would take me like 2 minutes to get to the elevator. So what do I want to do for time here? Well, it doesn't take a whole lot of time to get the mail, unless I'm walking. But maybe we'll say that we'll go by 2s as well. 2, 4, 6, 8, 10, 12, 14, 16, etc., 18, 20, and I'm going to start skipping, 24, 28, 32. It doesn't take me more than 30 minutes. I'm okay. 36, maybe, and 40. Okay. It shouldn't take me more than 40 minutes to get the mail. All right, so I'm on the 12th floor. Maybe it takes me, I'm going to draw this with a pen, so it's not going to be pretty, but that's okay. Maybe it takes me 2 minutes to get to the elevator, right? And then I go down to the first floor, or like the ground floor. We call it the lobby here. So I go down to the lobby, and usually it doesn't take 2 minutes. Oh, I don't even want to draw this. Okay. I'm going to even make it doesn't take me even a minute to get to the elevator, luckily. So I'm going to say, all right, well, I walk out my house, and then I get on the elevator. Well, maybe that's what takes a few minutes. Then I'm up here. But say the elevator came right away. Boom. That's me riding down the elevator, okay? It happens very quickly. 1 minute probably to go those 12 floors. So that's why it's a pretty steep negative slope there. And then, I'm in the lobby. I have to go and get my mail. So let's say I'm down there for 5 minutes. That's normal, right? Go down there, check my mail. There's a store, there's where I get my packages, whatever it may be. So I'm down there for 5 minutes or so. And then I'm lucky because I catch the elevator right away and head right back up to my apartment on the 12th floor. And then I can walk back. So maybe that all takes me I walk back to my apartment, takes me about 9-10 minutes to get the mail that way, right? Pretty quick. That's pretty awesome. All right, now I'm going to walk. All right, well, I'm on the 12th floor. Again, the stairs are right by the stairs are right by the elevator, right? But now I'm going to walk down 12 flights, right? And I'm going to pretend that I have like a constant rate. And it's easier to walk downstairs than up. Let's say it takes me, I would say about 12 floors, I don't know, like 4 minutes to go down. I could go down 3 flights a day. 3 flights per minute. That's normal. All right, I'm estimating here. It's not a big deal. So if I say it takes me 5 minutes now to get down, I'm at, well, 1 minute. So I'm going to go down and I'm going to say it takes me till 6 minutes to walk down those stairs. So the green is walking down. The purple is if I take the elevator down. All right, well, I'm going to still be down there for 5 minutes or so. So I'm going to just still be on that lobby floor, and that's going to be there. And then I'll say, all right, now I have to walk up the stairs. I'm going to give myself 12 stories. It doesn't take me a minute per floor, but if it did, or let's say it takes me 10 minutes to walk up the stairs, I give myself, I got to think about it. Like, logically, I take breaks, right? Let's see. I am going to say I could go up the first 6 flights of stairs in 4 minutes. Okay, so I'm going to start here. I'm going to walk up 6 flights of stairs in about 4 minutes. So that means I'm starting at 11, is what I'm thinking in my head. I'm starting at 11 minutes, so 4 minutes means I want to get to 15 minutes, right? Well, I'm not going to be here, though. I'm not going to be on the ground floor. I'm going to be on the 6th floor. I'm going to be somewhere up here, right? So I'm going to connect those 2 dots. All right, from here to here, I walked up the 6 flights, and then I was like, all right, well, I shouldn't take more than a minute. I will take 1 minute to get over here, take a break, right? Check whatever social media I need to, breathe, whatever I need to do. And then I continue. So I like this again, like this 5 minutes. That seems about right to walk up 6 flights of stairs, right? Don't judge, I'm not actually timing myself. So at 16, I want to get to 21, which is right here. So I want to get up there, right? But I'm doing that on the 12th floor, right? So here I am. I'm going to connect my rest break up to my rest of my ascent up my stairs. There's a nice little word for you. And then I walk back to my apartment, and there I go. So taking the elevator maybe takes about 11 minutes, so it's pretty quick, versus going down the stairs, hanging out in the lobby for 5 minutes, walking up 6 flights, taking a rest, walking up 6 flights, and then I would be back up on my floor. So those are 2 different ways to do those. Now let's look at a graph and see if we can go backwards. What story might this graph tell? And I see my face in the way. Try to move it. What story would this tell? Oh, well, a lot of times, I mean, you could think about, we've talked about time, right? But sometimes you're going to see it in other ways, especially like when you get to standardized tests and things like that. Time is usually your X variable, but you can really make anything your X variable that you want. We just like to think of it as the independent. But I might say, and when I was making this, I was thinking of a roller coaster, right? Have you guys been on a roller coaster? What this is, oh, again, time. I thought of it again, it's time. I was saying, all right, so this would be how high I am off the ground, right? And that could be anything. I could say, all right, this is, 25 feet. It's one of those ones you have to climb up the stairs. So maybe this is 100 feet off the ground, and it goes, I'm on the roller coaster, right? I get seated here, and then we're going to slowly move out of the place where people get onto roller coasters. And then many of you know that as you're going up a roller coaster, they just have you go up a little bit, build up that anticipation, right? Slowly I go up and then drop you off, right? And then I go around and I do things, and I didn't make this too, but then I go up again, maybe a little slower, and then down again really fast, and I'm getting off camera, but that's okay. And then maybe I do one more, whatever. Maybe this is a short roller coaster, but something like that. And there may be, we could use these more as quadratics as opposed to linear functions, but it wasn't coming out pretty when I was drawing it. That's really what it was. So you can tell a story from a graph, and that's what we want you to be able to do. All right, so one more example, and then I'll let you go. Remember, you can always pause and rewind and everything else here. All right, so here's another piecewise function, and I wanted to include this because it has a couple reasons. And I'll let you know. One reason was that it is, face. Nope, okay. It was It includes includes a quadratic, right? So we have here, we've been working with quadratics. We don't want to forget about quadratics. They look like a U. Here it is. 2, it's not continuous, right? I have here, this way I'm going down, and then I jump up here, and then I U, and then I jump up here, and I this way, right? And what is this for? Well, you're going to get a lot of this in algebra too. So like, I'm not going to get too far into it. We're just getting used to it. We're getting our feet wet. We're warming up to the water. Piecewise functions that we did before, connected. These ones don't. That's okay. This is how you'll see it on a math test, but this is what it can be, right? So we've used f of x before. I want you to be aware of f of x. I want you to know how to use f of x because it's important. We used to say y, we say f of x because it's showing us that x is the independent variable and the other variable depends on what x does. So as x moves, there's y. So we're making them more connected. So what they do is there's 3 things here because I have 1, 2, 3 different parts of this graph. This part of the graph is this. And let me show you why. If I put this in the calculator, oops, wasn't supposed to have that there. It's okay. Negative x minus 7. You've seen it. That's okay. This is that line, right? Negative x, so I know it's a negative slope. It's a -1 slope, so it's not too bad to draw. Minus 7, that means it crosses my y-intercept. My y-intercept, excuse me, is -7, so that's what it is there. That's the whole graph. But what it's asking us is only between, only less than -2. Let me just keep on going for that for a second. This one is x squared. So if I add that to the graph, x squared, here it is. Beautiful, quadratic, beautiful. And the last one is that y equals 6. All right, that's what they gave us. And there's some stuff here, but that's what it is. So these are my 3 full graphs. If I graph them and I didn't have anything, what we call constraints, these are the 3. That's it. They've introduced constraints. So let me show you. I just took a screenshot of that. That's why it was up there before. I forgot to delete it. This first one only exists when it's less than -2. So I have to think on my mind, -2 is right here. So that means this graph, this part of the graph doesn't even exist, or it isn't part of the function, isn't part of the function, right? This part of the graph doesn't, this part is, all right? So it's like I can erase that line, or sometimes I'll like put something over it. Let's see if this will want to work for me today. Sometimes it does, sometimes it doesn't, but I can just like kind of, if I just like almost erase it with this grayish color, right? So that part of the graph, boom, gone, right? My next bit is between, this what it's saying is between -2 and +2, right? And the equal to, we're going to get a little bit more into that, but there's a reason that equal to is important. This one, my green graph, my quadratic here, only exists between -2, I'll move this up, I'll have to move this over, between -2 and +2, right? So these other parts of the graph, like, don't matter, and I'll move that over because that's incorrect. I want to go to 2, right? So that's why it goes from -2 to 2, right? Now, unfortunately, the last part is just that y equals 6, and that's up here. That's that purple line. So I will need to because it starts at, so I'm going to go like, this part of the graph doesn't exist. Let's say this part of the graph. Now you can see the purple better. All right, and then, but this doesn't exist over here, right? All of that stuff, all this purple shouldn't be here because, I know it looks a mess, but you wouldn't graph all these. I'm just showing you that we're literally cutting them into pieces. That's piecewise, right? I'm cutting into pieces. So this graph exists over here, right? This linear function here, negative x equals, minus negative x minus 11. This is my quadratic. This exists before -2, between -2 and 2, and after 2, okay? And that's what that's showing us. Couple things I just want to point out on this graph a little bit more in detail, because sometimes I have a equal to, less than or equal to, right? And sometimes it's not. If, just like when we're graphing x is greater than or equal to 5, right? That's that closed circle, right? Same thing here. Here it's saying if it's -2, then it's this one. So at -2, that's why they colored this one in. I should color a different color. We just obviously both like purple. That's why this is colored in, is because it represents that. This is an open circle, right? Why is it an open circle? Well, it doesn't exist at -2. It exists at -1.99999 to an infinite number of nines, but it doesn't exist at -2. So we put that little circle there. But it does exist at 2, and that's why it's a closed-in circle. And then again, when it's 2, it's here. But as soon as it becomes 2.000000001, it's up here. So that's why we have that open circle there. It doesn't exist at 2, but everything beyond it does. Okay, so those are piecewise functions. This video is plenty long enough. I will, if you have any questions, please let me know. I'm happy to make any more clarifying videos, but I hope that this was helpful, and let me know if I can do anything else for you.